Hi, check this out. It's the classic Tandy 200. It's a Bobby Dazzler. Comes from my collection and, oh, look at that. Swing out screen. Isn't it beautiful? This is the follow-up to the Tandy 100. They'd actually dropped the TRS moniker by that time, and it's just the Tandy 200 portable computer. And it's a classic bit of 1980s vintage tech. It is, of course, the follow-up to the Tandy 100 and 102, both of which I have, and I've done a really old video on the doing a teardown of the Tandy 100. So I'll leave that in the link down below. And of course, it's got the classic modem interface and 6 volts DC in, and it runs from 4 AA batteries. Unfortunately, this one has lost its cover on there. Product of Japan, all the best stuff's made in Japan. Manufacture date 3/1985. Absolutely fantastic year, 1985. So there's a serial number for those playing along at home. Memory protection here. There's an extra memory slot here. Now, this thing did actually work when I originally got it. I've had it for a long, long time. But I took it out of the archives and check it out. Oh, unbelievable. It works. It works. I swear, it wasn't working. This was supposed to be a repair video. Let me turn the lights off. Bloody Murphy, would you believe it? This was supposed to be a start of a repair video. Let me try that again. Sorry, the screen is really quite dark. So let's turn it off. Let's turn it back on again. No, there it is. Damn. I swear this thing was like faulty multiple times before I started this video. Unbelievable. Oh man, I can't cop a break. And it was it had a noise coming from it, like a tick 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 noise like that. Like there was some sort of like power supply magnetic thing trying to start up and it couldn't do it. Something like that. So, but it's working every time now. What the heck? Oh, come on. Ugh, man. I can't cop a break, seriously. There you go. That is probably the best angle I can get for the screen. It's actually, it's quite reflective, and it looks better in real life than probably what it's going to show up on camera here. But there you go. I can use basic. Yeah, everything's hunky-dory. What the heck? No, oh, I could hear that little click when I turned on. Well, so much for that. I had just set up my bench over there to, with the microscope and everything and the on-screen scope and the whole works. I was going to troubleshoot this and nope. Bloody thing works fine. Anyway, I know what I saw and heard, so I decided to crack this thing open anyway. There's just 4 self-tappers in the corner like this, and the top just pops off, and there's just a little LCD ribbon down in there, and that just came right out, and oh, Bob's your uncle. There's not much to it. It's actually a rather nice design, as was the original Tandy 100 as well. Now, of course, what we've got to worry about is what's going on in the power supply here, and is that a Vata? I think we have Vata. We have Vata. These are, of course, the vintage computer Widowmaker. They will famously leak and destroy motherboards, but, this is from 1985, so this is 40 years old, and you can see it's a little bit crusty there, but she hasn't leaked. Wonder what voltage it is. Check it out, we have the new EEVblog BM2257 meter. It's an upgrade to the BM235. It's a Bobby Dazzler, available on the EEVblog store, which is at eevblog.store right now. Check it out. And it's even got, orange backlight. Look at this. So let's actually measure. It's got 4.27 volts. And yes, this does have a bar graph. Isn't it great? And it's got auto hold as well. Look at this. I can whack auto hold on, go like that. Beautiful. And hands-free. No whackers. But still, that is pretty crusty, so you would change that as a matter of course. Are they easy to get? I don't know. I'll have to look at it. Well, a modern replacement anyway. So, yeah, I don't know what was causing it to hiccup. Basically, the power supply was hiccuping. The caps look okay. There's no leaky deaky there. So I'm not sure what the deal is there. Just got a little common mode choke going in there, but yeah, I don't know. It's working now, that's all I know. And really, there's bugger all in the way of magnetics in there that can do the shake, rattle, roll when I powered it up, because I was hearing this clicking noise. So I suspect that might have been coming from the buzzer down there. Power it on again. Yeah, I can hear a click. I can probably narrow that down. Yeah, I think that's coming from the buzzer. This would be a rechargeable battery, and I had the, I still had the AA batteries in there, so that would have been feeding in the voltage. So I've taken out one of the batteries now, so let's see what it's got. And sure enough, it's dropped, and it's going to continue to drop. So yeah, anyway, I'm about to head home, ran out of time, so I'll actually leave that, and I might come back in a couple of hours and see what that's like. But yeah, of course you would replace that as a matter of course after 40 years. That's just absolutely nuts. So yeah, and of course it looks, it's got all hairy scary on the end of it. So yep, definite replacement. Right, it's a couple hours later, I've come back, and what do we have? Yeah, a 1.7 volts. So, yeah, that's Kamagutsa. Yeah, you don't expect the nickel metal, well, no, that'd be NiCad, wouldn't it? Back in the day, didn't have nickel metal hydride rubbish back then, did they? Anyway, you'd expect it not to be too great after 40 years. So I suspect what might actually be happening here is that when it first comes out of storage, this thing's flat as a tack, of course, and you try and boot it up, and it's just continually resetting. Like, it was doing it like a couple of times, like more than once a second, like I was hearing tick, 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 tick. So I might actually power it up again, given that it's pretty much not a voltage that's going to sustain the memory anymore. So we'll give it a go. Oh, I'll tell you what, they were not thinking about assembly when they made this. It's, yeah, ribbon cable's too short. Don't you hate it when your ribbon cable's too short? And that's what she said, and maybe I can, thankfully the flap is this side, and maybe I can get that in. Oh, seriously. Nah, I think I got it. If you leave the screen at like 45 degrees, it's like has the most ribbon cable on it. All right, let's give it a go. No. Oh, damn, it works again. Still works, and it's still in basic where it was before. So it did retain that, that battery was enough to retain that SRAM. Oh, geez. What do I have to do, short it out or take it out? So I suspect what's happening here is it's not the power supply hiccuping, it's the processor resetting somehow. Maybe because the battery wasn't charged and it's like pulling it down. Maybe the design of the charging for the battery is like pulling down the actual batteries and the voltage going to the processor, and that's causing it to reset. We'll have to look at the schematic for that. So yeah, so I think once the battery is regained enough juice in there to not be a burden on the rest of the circuit, then the processor gets enough voltage and it boots up fine every time. But if you let that thing discharge too much, then you're going to Kamagutsa. So let's measure that voltage again, shall we? And yeah, 780 millivolts. So yeah, that is quite low. The batteries have been disconnected for like a day now. So yeah, that sucker's not holding too much charge. I couldn't get a replacement for this at the local JCar store, so I couldn't just go get one. So I have ordered one. So one is on the way, but I don't have it to hand. Anyway, I thought we'd take a look around the rest of the board here, shall we? Let's have a squiz. Oh, look at this. All the best stuff's made in Japan. There you go. It's a 4584. Oh, geez, my memory's getting too old. Offhand, I can't remember what a 4000 CMOS. I should be able to remember that. I knew this when I was a kid, but it's been a while. I almost found myself typing on the Tandy 200 keyboard to surf the web. Oops. Sure enough, hex Smith trigger. There you go. I should have known that. So that's associated with the RS232 port here. Got some 100K pull-up resistor network there. So that seems associated with this RS232 port, but Yeah, it doesn't have your usual RS-232 transceiver in there. Anyway, there's not much on the power supply side of things. As I said, there's a common mode choke. There's an inductor in there. That's a little transistor package. Look at that jobby there, ST. Oh, neat. Anyway, we've got some diodes up here. This is our reset switch here. So that's just a momentary jobby. Yeah, we've got our DC input here. And of course, the rechargeable battery is designed to actually protect the RAM. This is the ROM. There it is. Copyright 1984 Microscope in the head. And they're socketed, so I could actually read the ROM out of that. Nice, as I said, LCD interface. This is the system expansion connector. And we've got some memory down here. But of course, you've got memory expansion on the daughter board, which is actually under the keyboard here. If you flippity-doo that, here you go. And you lift up this insulating sheet. Nice. This is the memory board, which you can access from a panel on the back there. And that actually, from memory, had an additional ROM. So if you flip that open, there you go. So it has 2 option RAMs here. So we do actually have, look at that, Tandy, a genuine one. You can get aftermarket updates for this, I think. You know, some people actually sell them, I believe, but option RAM, the second option RAM slot, and I think that was a ROM slot, wasn't it? Off the top of my head, I can't remember, but memory protect switch. So if you put it on, then that backup battery will actually protect your RAM in here, because there was no solid state storage. Remember, no E2 PROM back then, let alone flash. So yeah, the only way you actually kept it in SRAM, volatile SRAM, backed up by that battery. But you could specifically switch that to off. So if you switched it off, you lost everything. So if you spend a week typing your basic program or your document or whatever, yeah, you've lost it. If you didn't have the memory protect switch on and that rechargeable battery wasn't any good. Down the bottom here, there you go. For you 8085 fanboys, it's upside down, so all the electrons are going to fall out. NMOS rubbish, CMOS, thank you very much. 80C85, that help keep the power consumption down, of course. And we've got an Oki 8251. And bingo, that's our UART. There you go. So, 64K board. Awesome for synchronous, asynchronous, 38.4. Fantastic. So, yeah, so that's our UART all the way down there. So, and our RS-232s all the way up there. So it gets across there somehow. And it's just more 4000 series CMOS, because this is a low power design. You've got to remember this. Well, the 100 had a 20-hour battery life. I think this was similar, even though it had a bigger screen, wasn't it? And that Hitachi jobby, of course, Hitachi, famous for their LCD drivers. So that is an LCD driver, and sure enough, yeah, so that stores the display data sent from the micro there, graphic mode. So this can do 512K dots, 4,096 characters. This was 192 by 128 pixels or something like that. So they could easily do the job there. That's really interesting. Is that like BLA? No, I didn't find anything for BLA 5080. That could be something else. So we'll have to have a look at the schematic. But you can see that's directly connected into the ROM over here. So I don't know, is that some sort of gate array jobby? And this 81C55 here, I didn't know what this was, so I had to look it up. It's a 2K static RAM, but it's got I/O ports and a timer. 100 microamp standby consumption. 400 nanoseconds, yeah, it's designed for ADC85 systems. Yeah, it's got 2 8-bit ports, and a programmable counter timer, which may be used for sequence generation or whatever you want to use a counter timer for. That's fascinating. That they wouldn't be using the 2K as part of the main memory, so what are they using it for? Oh no, 256, okay, 256 bytes, so it's not much. So I don't even know if they're using that or not, whether or not they're just using it as an I/O port. Interesting. Guess we could get that from the documentation. So moving over to here, we have more analogy goodness. We've got a Philips jobby over here, a TCM 5089. And sure enough, that is a tone decoder there. That is, of course, for the modem. They're detecting the tones on the modem, because this is all part of the modem stuff in here. So yeah, I think that's the modem interface there, and that one's the cassette over there. So yeah, is that I was going to say, is that like a relay? That's a Fujitsu. Yes, of course. And the only hits I get are like the Tandy 100 service manual and stuff. So yeah, oops. And then we've got barcode wand interface over here. And as I said, I believe that's the cassette interface there. So yeah, another 4584 there. And that's about all she wrote here. This is a answer originate switch or whatever it is for the modem. We've got one trimmer pot there, and that's about all she wrote on that board. So we've got a crystal down here for the 1441, and sure enough, that's a universal low-speed modem, 0 to 600 bits per second. There you go. So it does all the FSK stuff and everything else that you need for the modem functionality. So cool bananas. Yeah, so that's all the, pretty much most of that is like the modem interface, and they've got a dedicated crystal for that. That'd be 1,000 kilohertz, would it? That's not 1,000 megahertz. It'd be 1,000, so that looks like 1 megahertz there. And up here seems to be our main crystal, our 3.597945 NTSC color burst frequency, of course. I think that's all she wrote on this Tandy 200. It's really quite nice and simple. A mix of discrete and SMD in the mid-80s, as you'd expect. But, yeah, cool bananas. Let's look at the service manual. And as you'd expect, the service manual is excellent. They don't make them like they used to. Of course, I've done a video on scanning in the Tandy 1100 FD laptop service manual that the whole community was dying to get their hands on, and I just happen to have a copy. So I'll link in that video if you haven't seen it. But of course, look, they got troubleshooting, they got theory of operation. Nobody does theory of operation anymore. You used to get this in the magazine articles. When you published a project in a magazine, you had to have a theory of operation. And yeah, and they'll have block diagrams and timing diagrams. And, oh, look at this. Look at this. It's a thing of beauty. A joy forever. Aha, that is a gate array down there. Yeah, that other chip. Yes, gate array. There you go. SLA 5080. There you go, not BLA, SLA. Yeah, there you go. I could have just got it from the block diagram. Potentiometer VR1 for modem transmit level. There you go, that's what that trimmer is. Yeah, tone dialer IC, crystal for tone dialer. Yeah, PIO interface, which we looked at. And the ROM and the RAM. Oh no, the main crystal's down the bottom here. We missed that. And I won't do a teardown of the LCD, but look, there's the segment drivers on there. And do they have cutouts in the PCB like they did in the Tandy 100? Of course, they had cutouts in the PCB. They flipped the chips, and I explained that in the teardown, and that was for PCB routing reasons. So check out my Tandy 100 teardown video for that. So there you go. For optional RAMs. Oh, so there's actually more on that memory expansion board than we saw. Okay, so the standard RAMs are on there. Okay, 3 kilobytes, 8 kilobytes. So yes, that's right. 24 kilobytes standard, and then you could expand it with 2 optional ones. And then yes, the optional ROM there. I can't remember what you got in the optional ROM. Extended basic or something, or I don't know, some other apps or whatever. Oh, it's got a Ricoh timer IC in there as well. Anyway, that's interesting. The specs for those playing along at home, 240 by 128, and there's the duty cycle. Operation time, 7 days. Name a laptop these days that gets a 7-day battery life, let alone from a set of 4 AA's. Fantastic. Well, that's at 2 hours a day usage. Anyway, fantastic. Right, so that rechargeable battery would last about 15 days with 24K RAM and 5 days if you expanded to the maximum of 72K. So it's really only designed for like when you change the batteries and stuff. But if you left it there for a couple of weeks, without the main batteries in, you might come a gutser. You've lost everything. If you didn't save it to cassette tape. 72K of standard ROM there, incremental 24K memory, yep, and it weighed 4 pounds, 4 ounces for you Yanks. RS-232 modem coupler interface, audio cassette interface was 1500 bits per second, there you go, 2400 and 1200 hertz signals, you just store it on your cassette tape, fantastic stuff. There you go, how to disassemble it. Beautiful, but I'm not going to do that in this video because there's not much interesting to see there. Modem transmitting level adjustment. Oh, don't you love it? I just set up the Tandy 200 in basic mode and enter the following command to generate the carrier signal. There you go. You just use an out command and it'll generate the transmit signal, and then you can to put your analog VOM on there. None of this digital multimeter rubbish. terminating 600 ohms. Thank you very much. And general theory of operation. So yeah, look, we won't dwell on this sort of stuff, but yeah, they go like, nobody makes manuals like this anymore, do they? Leave it in the comments down below. Last time you've seen a computer with like a theory of operation. I don't know of one. There's the keyboard. This has a beautiful keyboard, by the way. It was highly sought after by journalists in the field, as was the Tandy 100, of course, because the keyboard was awesome. Cassette interface, the write circuit, the read circuit. Oh, it's great. The remote circuit, what is that? Oh, that's the remote control for the cassette interface, right? Printer interface, barcode reader was pretty simple, of course. It's just what using it. Oh, is that M1 one of those Schmidt triggers? They don't have the Schmidt symbol in there. Geez, complicated for driving your buzzer, isn't it? But that's the thing that was, I believe, ticking at me, going tick, 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 when it was resetting. Clock control circuit. Oh man, all the addresses, everything. Look at all these flow charts. Just fantastic. RS-232 interface circuit. Modem IC. There you go. Transmission filter circuit for the modem. Reception filter circuit. Oh my God. It's just wow. Wow. Yep. These sorts of manuals just make it a joy to work on these old machines. They're just everything's there. All the LCD stuff, common driver, yep, segment driver, yep, LCD waveform data, beautiful. So here's what we're interested in, the power supply and auto power on-off circuit. Looks like VDD, VEE, VLCD, yeah, plus, yep. So power distribution. This is what we want. This is our power interface. There you go. We've got the input DC connector here, which has a disconnect. You might think that power goes straight onto the battery, but it doesn't, because when you insert the plug there, this lever lifts up and then disconnects the battery. Otherwise, if you've got no DC plug in there, the battery, this is the 4AA batteries, so that's the main power there, and then that just goes through to, I don't know what that jumper link there is, J302, but here's your memory power switch, and that's a double pole, double throw jobby, and here's your internal rechargeable battery that we want to replace here, and so yeah, when you switch that memory protect switch off, you don't get to power any of the DC to DC converter stuff here, or going off to actually power VB, which would be V battery going over to that memory board, I'd imagine, which keeps your SRAM alive. So yeah, so there you go. So they've just got a diode and resistor there just to trickle charge the battery there. They don't put values on the schematic. That's interesting. Yeah, they only put they only put designators there. Although this resistor here and these diodes don't have any designators. So there's a lot of work that's gone into that that power control and reset stuff. So yeah, as I said, like if that voltage level on that internal battery is not enough, then I think we're just going to get it continually resetting. And I think that's what I was hearing. I was hearing the reset hiccup going on there. I think that's what that was. Oh, and they explain how the DC to DC converter, theory of operation, low power detect circuit. Yep. Okay, when the voltage decreases, system power was switching off. Yeah, so I think it was, I think something was oscillating there. And you would get that with the battery chemistry, because the battery chemistry, if it's just on the margin, when you put a load on it, it's going to drop, and then this, the system resets, which will be presumably a less load, and the voltage goes back up again, and then goes back down, and it just oscillates around that low voltage point. So like it reset. Oscillates, so to speak. So there you go. There's your DC to DC converter for getting your LCD voltage and your VLCD and VEE there and VDDD. So there you go. That's what that transformer that was there. There you go. Very old school discrete transistor DC to DC converter there. Classic. Anyway, look at this troubleshooting guide. Buzzer, does the buzzer function? No. Does this and that work? And go through all these checklists. It's just brilliant. It's just absolutely fantastic. Anyway, technically we're not at the schematic yet. And here's your bill of materials. Wow. Yeah, what we were seeing before was like, that's why I didn't have some reference designators on there, is because we were just looking at like a top level theory of operation, like a block diagram kind of thing. So we should find ourselves after we get through the extensive BOM, we get our schematic. There you go. Anyway, so there you go. So there's our DC input jack, and you can see that's our AA batteries there. And, ooh, is that a look at that, a thermistor. Good stuff. Where's our internal battery? There's our reset switch. So that's our reset circuit. The thermistor's part of the reset circuit. Okay, if it overheats, it resets. Ooh, tantalum, be afraid. Look at that. You don't see flippy floppies like that anymore. So this is very cool bananas. There's our ROM and our RAM. RS-232 interface there. And there's that gate array. Do they have details of what's inside the gate array? So they've obviously scanned this in on and spread over multiple pages there. Yeah, there's our memory power there. So they've got a 1 mic there just to keep that alive. Oh, and that's it. And then we've got our PCB overlays and stuff. So I must have missed the rechargeable battery. Oh, totally overlooked it. There it is there. I'm not going to go, I don't need to troubleshoot this. I think if I just change the battery and charge it up, she'll be right. Because it's working absolutely 100% every time now. Although, I will now repower it up with the battery in that low state. In fact, I might actually discharge the battery completely and then try and start it up again. So I shorted out the battery with the current range. It didn't give me much, but you see that the voltage is actually recovering there. Recovering due to the electrochemistry in there. It didn't like me shorting it out, but yeah, come on. Everything has to be dead by now. Okay, I'm going to see if I can get this thing to hiccup one last time. So, whacking my batteries in there, and they should stay in. And, oh, I've got to 3D print myself a door for that thing, I think. If anyone's got a file, let me know. Bloody hell. No! No, it works! All right, I'm not giving up, damn it. I'm powering it from an external power supply here. So let's switch the output on. 6 volts here at 0.5 amp. Oh, channel 1 helps. And there we go, 1 milliamp. Switch it on, no wuckers. Let's see what she does at 4.5 volts here. That's fine. Let's drop that to 4 volts. We get our low battery lead there, so turn it back up. What? No. Okay, it latches. Looks like it latches the low battery lead on. So let's do that again. 4.2, 4.1, and 4. Yeah, so it comes on at 4 volts. And I don't know. So, oh, there we go. There we go. She came a gutser at about 3.7 there. And no, yeah, it still powers up at 3.7. 3.6. No. There you go. Low battery. No, 3.6. But I suspect I'm not going to be able to get it to hiccup because, as I said, I think it might be the electrochemistry of the batteries doing the business there. So, yeah, nah. I was just playing around with lowering the voltage on this, and I seem to have locked this thing up, like, permanently. But, yeah, so I had to, like, go in and discharge the rechargeable battery in the thing, like, completely discharge it, and, like, even the reset button on the back didn't help or anything like that. But I eventually got it working again, so it's fine. So what I'm going to do now is basically simulate a battery, or simulate the ESR of a battery. So I've got a resistor in series. I've got, like, 1 ohm at the moment, so I'm powering it from 5 volts, and you'll see it powers up fine. So let's just change this around. So let's go up to 5 ohms and see if that will boot with 5. Yep. Let's keep going. Let's go up to 10. 10. I'm going to have to go there. 10 ohms. Bingo. It won't boot. Yeah, I can't replicate that. Notice it's taken 80 milliamps there and we're getting nothing on the screen. So I might have to physically disconnect that completely and reconnect that. And at 5 ohms, no, it's not working again. Let's try that back to 1 ohm. No, there you go. I've locked it up again. I've done that lock up. And let's try the reset button on the back. No, reset button doesn't do it. Damn. So it looks like I can't get it to replicate that sort of cycling that I swear happened, that I didn't catch it on camera. Anyway, it doesn't really matter apart from not giving you a very exciting, well, this wasn't a repair video. It's basically a teardown, but yeah, I'll just install the new battery in this thing when I get it, and yeah, that'll be it. It'll work fine. And I took a look, and you can actually buy, even on eBay, like a ROM board for this thing, like that plugs into that ROM expansion at the back. And you can do all sorts of fantastic stuff with this. You can hook it up to a modern PC via a null modem cable, so it acts as a drive, and you can transfer files and stuff, and you can, you know, do lots of fun things with these Tandy 100/200. It's basically the same as a Model 100, like especially in terms of software and stuff, except it's got the bigger screen and, you know, the slightly nicer keyboard and stuff, and the form factor and the big flip out screen, which is better. So yeah, but apart from like software, apparently like the 100s and 200s, pretty much identical. So even though we couldn't reproduce that, maybe I could if I dick around some more or something like that, but it's not worth the effort. There was nothing actually wrong with this thing. Unbelievable. But I was going to use my battery simulator here, the Keithley 2302, which I've done a teardown video of, but I powered it up and just the screen is completely blank. So I don't know, the vacuum fluorescent display in it's failed. Maybe. So I might get a repair video out of that one. Catch you next time.